Hello everyone, it's Shirley Becker and welcome back to my channel. I studied natural sciences at the University of Cambridge and graduated in 2017. I'm now studying graduate entry medicine again at the University of Cambridge, and I will be graduating in 2023, so that's a long time from now. Today I'm going to be making a video that I've actually wanted to make for quite a while, which is advice on A-levels. From the age of 16 to 18, every student in England will be studying either a sixth form or at a college, and here they'll be obtaining their A-level qualifications, which they'll use to apply to a university. When I did my A-levels, which was back in 2012, 2013, I sat the 3 sciences and the maths. So back in my day, we had a different structure to what we have today. Back in my day, we had a structure which was the AS and the A2. So we did half of our course in the first year, so year 12, and half of our course in the second year, so year 13. And we sat exams at the end of each respective year. For my AS, I did biology, chemistry, physics, and math. And for my A2, I did biology, chemistry, and math. So in this video, we're going to be covering the tips and advice that I have for students studying for their A-level chemistry. So there's going to be a little bit of structure to this video. In the first part, we're going to talk a little bit about what chemistry is, what the aim of the course, the A-level course really is. In the second part, we're going to look at recommended resources, so the books, the websites, the things that I use. In part 3, we're going to specifically look at the study techniques I use. So did I use flashcards? Did I use posters? I'm going to talk a little bit about that. In part 4, we're going to look at assessment, so how I self-assess in order to best prepare myself for my exam. Finally, in part 5, we're going to talk a little bit about those of you who are interested in pursuing chemistry beyond your A-level qualification and what sort of things you could be doing to best prepare yourself. So without any further delay, let's roll into the first part of the video. A-level chemistry, in my opinion, is really aimed at introducing a student and getting a student familiar with the chemistry of life sciences. I always think of the sciences as scales. I think that biology kind of gives an overview of the macroscopic scale of life sciences and what's kind of going on. This is what diabetes is, this is what happens during diabetes, this is what medicines you can use to cure diabetes, and it's all kind of on a macroscopic scale that we can relate to because we see each other. I then think that chemistry kind of goes into the actual chemicals behind life sciences, again, as I say. So with chemistry, instead of talking about insulin and just giving the name of the drug, we might look at the structure of insulin and why that might be compatible to the receptors that it attaches to. I mean, this is not actually what you'll be studying, but that's the level that we're looking at. So not a level that we can see with our eyes, but on sort of a chemical level. So the A-level course is split up into organic and physical chemistry. Physical chemistry predominantly being calculations, organic chemistry being organic compounds, so carbon containing compounds. Topic that's introduced in A-level chemistry, which was absent in GCSE chemistry, is mainly drawing mechanisms. And this is something that students find really scary and something I'll address a bit later on in the video. But yes, chemistry in general is to be able to understand life sciences on that scale. So the scale of the atoms, the scale of the compounds, rather than kind of a macroscopic scale that we see day to day. So now in part 2, I'm going to talk a little bit about the recommended resources. So in this part, I'm not yet going to talk about the study techniques that I specifically use. That's coming in the next part. So for A-level chemistry, I kept the resources very, very, very simple. There were 2 main things I used, and those 2 things I'm going to show you now. For GCSE chemistry, BBC Bitesize was like my haven. I used BBC Bitesize for all of my sciences, and I just thought it had all the information. It matched up very, very well to my exam. And yeah, I mean, that was my favorite thing to use. I think still to this day, BBC Bitesize does not have pages for the A-level qualifications. I actually emailed BBC Bitesize when I was 16 to ask if they would be creating any A-level content just because I relied so heavily on it during my GCSEs. They did email me back and they said that they were not creating content for the A-level because the demand for GCSE is obviously much higher because the entire country takes the GCSE science. However, the demand for the A-level is much lower because it's a chosen subject. It's not compulsory, and so only a fraction of the population does it. I then had to find new resources, and there were 2 things I used. For me, the absolute key to finding the perfect resource is finding the resource that best matches your exam board, that best matches your exam, that uses the exact wording that you can see on the mark scheme, which I'll come to a little bit later, but that basically teaches you in the way that your exam wants you to write the content, okay? So I did AQA chemistry, So my exam board was AQA chemistry. So there are two things I used. The first thing I used was the CGP A-Level Chemistry AQA guide, okay? So this is revision and practice. I know a ton of teachers will say, this is just a revision guide. It's not comprehensive. You can use this for revision, but you can't use this for study. I used this to study, and this covered every single thing that came up in my exams. But this book, I actually think is great. I was a teacher for a year, between doing NatSki and between doing medicine. And I taught GCSE chemistry. There's a GCSE version of this book. And I based all of my lessons on the revision guide, just because I know that this book was straight to the point and kind of cut out all the fat. I would say that if you read parts of this book and some of it was not making sense to you, then use one of the sort of bigger books to supplement your study so that it gives you a bit of background. But when it comes to taking notes and really condensing your notes down, this book is very brief, to the point, in line with the exams, CGP for me all the way. So for my second resource, I absolutely use the exam board website that I sat my exams with. So if you use the Edexcel chemistry, you go on the Edexcel website. If you use the AQA chemistry, you go on the AQA website. If you use the OCR chemistry, you go on the OCR website. I don't even know of that many exam boards. And I'll talk a little bit about why in a subsequent part of the video when we cover self-assessment and examinations. So I'm just going to leave the screen on here while I move on to the next part of the video. So in the next part of the video, I'm going to cover my revision techniques. So in terms of my revision techniques, because chemistry is sort of a mixture of mechanisms, understanding content and calculations, I would feel that writing pages and pages and pages of prose is not the most effective study technique. I would say look for patterns, look for things that repeat themselves, look for ideas, things that you need to memorize off by heart. There are some mechanisms that you need to memorize off by heart. There are some methods of calculations that you need to memorize off by heart. And I would say make condensed notes on those things. So for example, titration calculations. They came up in GCSEs, they've come up again in A-levels. Titration calculations always follow the same methods. They always follow the same methods. You're going to have to find the concentration of some kind of compound is always what you're going to have to calculate. So I would create just one or half a page that just reminds you of the technique to find out the concentration in a titration question. And that's 3 marks in the bank. I don't even know how much titration questions are worth these days, but just condensing the information. So I don't want you to write notes the size of this book. It needs to be much more condensed. The other tip I have for condensing your notes is while you go through the content, there are some things that will feel intuitive to you. There are some things that will feel familiar to you. And there's some things that you know you're going to need reminder of. The things that are intuitive to you, do not take comprehensive notes on those. Do not make flashcards on those. Do not clutter your memorization techniques with the things that are intuitive to you because you already know them. What you want to have is condensed notes on the things that you need reminders of. So if you need a reminder of how to calculate concentration in titration questions, then you have half a page on that. If you need a reminder on how to draw this mechanism, you need a page on that. But you don't need to clutter your notes with pages of things that you know off by heart already, that are intuitive to you, or that are easy for you to understand. Because what it will then feel like is when you want to pick up those notes and revise, the notes is 50 pages long instead of 10 pages long, and it will put you off revision. So kind of as a psychological effect, I would, condense the notes so that the getting through them is a very fast process. Okay, so in terms of how to make your notes as condensed as possible, I would say identify the calculations that come up all the time. So just like I said, titration is an example of one of them. Maybe the Gibbs free energy, and recognizing how, actually, I'll come on to that. So maybe the Gibbs free energy one. If we go through the book, the first page of the book talks about atoms, talks about the charges of a proton, neutron, and electron. These are the things I don't want you to note down in your book because they should be intuitive to you now, seeing as you've done the chemistry GCSE. It shouldn't really be up until the part where they talk about Rutherford experiment to determine the structure of atoms. This is quite comprehensive. When it comes to you writing the notes, it needs to be diagrams and things that remind you of the full sentences, okay? So perhaps just this diagram here, if I don't know if you can see from that far, this diagram here showing the arrows going through and some arrows bouncing back. You don't need to write, you know, some of the alpha particles went through, which indicates that there was space. Some of the particles bounced back, which indicates that there was a positive mass, okay? This diagram, after reading this, should be able to remind you of what that represented. And I want you to be able to condense your notes down so that a diagram or a table or something kind of summarizes the entire prose behind it. And this takes practice, and this takes you recognizing what things remind you of what. And if I do a video on advice for A-level biology, perhaps I'll show an example of that. A lot of things in A-level chemistry are, when applicable for one thing, are applicable for lots of different things. So if you're going to take notes and you want your notes to be condensed, you don't need to write down every single example where it applies. So a good example for this is in the nucleophilic addition elimination question. So this is a nucleophilic addition and elimination attack on acyl chlorides. We've got a nucleophile attacking the carbonyl-carbon because it's got partial charges because of the difference in electronegativities across the carbon and the oxygen. Anyway, this is the mechanism for it. You don't need to write in all of the mechanisms for it with water, for it with amines, for it with ammonia, because the same thing happens again and again. So you actually only need a note that stretches this much across your page, not a whole page full of all the mechanisms, just one general mechanism that represents the nucleophile as just a nucleophile. And then underneath, you could just write a note to say where the nucleophile can be H2O, where the nucleophile can be an amine, where the nucleophile can be ammonia, where the nucleophile can be, etc., etc. Okay, so then you know that this mechanism, as soon as you see an acyl chloride, you can use water, amine, ammonia to do the same mechanism because they have all of the same subsequent steps. It's always the nucleophile attacking the carbonyl-carbon and the oxygen receiving the lone pair. The oxygen then using its lone pair to reform the double bond and kick out the chlorine. That does not change whether you use water, amine, or ammonia, okay? So you don't need to write down every single mechanism with every single possible nucleophile. Condense your notes to make revision much easier. So just to summarize again, I would use the CGP A-level chemistry book to study the content. On the contents page, they show the different topics that they'll be covering. So not the whole units, the different topics that they'll be covering. And after studying each topic, I would then make summarized notes of the things that, first of all, I know I'm going to forget, and then how to sort of capture all of the content into a diagram or into a table or something like that. So for each of the content. So that's the first step of my study technique, to kind of get through the content. The second note that I need to make about doing that is it's very, very, very helpful if you do this before you have the lesson at school. You want the studying at home to be the studying and the lesson at school to be the revision, especially if you go to a school that is not a very good school. Sometimes teachers don't know what they're talking about. Sometimes teachers get it wrong. Sometimes teachers, in my case, just don't turn up. And so it's very helpful if you are self-dependent and you don't depend or rely on your teacher, because teachers can really mess up your future. This is not a joke. Teachers can really mess up your future. So this segues me on to the next part of the video, which covers self-assessment, which would be the next part of my study technique. And this part is absolutely imperative. Self-assessment is absolutely imperative. You will not score the top marks if you are not someone who looks at what they're going to ask you in the exam, looks at what answers they expect you to have, and learns how to kind of consolidate the exam using all the things you've learned, you know, on the day of the exam. What I'm about to say was absolutely the turning point of, you know, being able to sit the A-level science and maths exams. Doing past papers is imperative. Past papers, say it with me, are imperative. Past papers are imperative. Past paper questions are basically your golden ticket to being able to answer the exam questions, because past paper questions repeat themselves. Past paper questions allow you to spot patterns, and past paper questions allow you to see how all that content that you've been studying for is actually asked in an exam format, okay? And this is why the examining board page was such an important page. So if I go onto that page, so if I even taken a step back and I go on Google and I search for AQA, this will take me onto the AQA website. From the AQA website, you can then click on past papers. You can then type in your subject. You can then type in the qualification, and then you can find your specification for which chemistry there's only one. And then the exam papers available are 2016, 17 and 18. I must admit, when I sat my exams, there was a much larger pack of exam paper questions available to you. If you can get your teachers to get their hands on the papers pre-2016, those questions are still applicable. Chemistry hasn't changed since before 2016. So saying that your past papers available to you isn't as vast as they were back in the day isn't an excuse. Chemistry hasn't changed. The questions they asked then look very similar to the questions they ask now, except sometimes the mark schemes change a little bit over time. And you will notice that as you go from 2008 to 2018, that some answers stop becoming appropriate. For example, you click on 2016 and then you can find the papers just here. So they have the insert, which is the slip that you get with your exam. So for A-level chemistry, you get the absorptions for IR. So if you've done spectrometry, you'll know what that means. You get the periodic table as well. So make sure that when you study, you use the insert. So print the insert off now, print them off now. And you use the insert to study, because this is the exact same piece of paper that you're going to get when you sit the exam. And being able to, I don't know if it's just a psychological thing for me, periodic tables sometimes look a little bit different. And being able to know, I know on this periodic table exactly where, this is placed, or I know exactly where to find these respective IR absorptions, kind of saves you a little bit of time in the exam. Okay, so they give you that, and then they give you the exam paper. So this exam paper was the real exam paper that people in 2016 sat for their A-levels, okay? So this is the exact paper that they got. The mark scheme that follows is the exact mark scheme that it was marked with. And what you can do after you finish the content is attempt exam paper questions and attempt many of them before your exam. Attempt as many as possible before your exam, okay? And what you should then do is go on to the mark scheme and mark your exam paper as if you were an examiner. Don't mark it like, oh, I knew what I meant by that, I just wrote something different by accident, or oh, I would have got that if I wasn't tired. Mark it as if you're an examiner and be absolutely crude, be cutthroat with it. And what you'll see is slowly you'll start to memorize answers off by heart. Slowly you'll start to see patterns. Slowly you'll notice from the first few words what they're about to ask you, because the style in which they ask you the questions doesn't change. In general, the questions don't really change. And so this is absolutely the best way to become as familiar with the exam as possible. I don't know what else to say. If you don't do exam past questions, good luck to you. I had done so many exam paper questions by the time that I sat my exam that I knew what the comment box would say. So sometimes they ask you to write down they ask you to write an answer to a question, and in the comments box, it tells the examiners allow phonetic spelling. So if someone can't spell it properly but they spell it phonetically, there is phonetic spelling allowed. And I knew at what questions it would say allow phonetic spelling, because I'd seen so many mark schemes. I knew what the mark scheme would say, and that's why I was good to do the exam, because I'd essentially done so many of them in my bedroom. You'll just know exactly what you need to say for what mark. It tells you exactly what you need to say to get marks. So just to cut out all of the ambiguity, just for goodness sake, do exam paper questions and look at the mark scheme. So in the last part of the video, I just want to address the people who are thinking of possibly pursuing chemistry past their A-levels, and how they could best prepare themselves. Unfortunately, as you've learned from GCSE, everything is a lie. You do GCSE chemistry and it's like, okay, right, electrons, 2, 8, 8, 8, 8, 8. And then you get to the lesson on electron configuration and the teacher's like, no, it's 1s2, 2s2, 2p6, 3s2, and you're like, what on earth is going on? I thought it was just 2a. Unfortunately, that trend in it wasn't lying kind of continues into university. So believe it or not, you might think you're at your maximum capacity now. A-level chemistry is quite a simplified story of, you know, not necessarily of the reality, because the things that they're teaching is what's going on, but there's, you know, reason and method behind it, and that's sort of the things you're going to go into when you go to university. Trust me, it will become even more microscopic, even more enjoyable. Cambridge students suck out the fun out of my love for chemistry at all. Some of the things you can do to best prepare yourself for that without, you know, deviating away too much from the A-level, because you don't want to deviate away so much that you're not in line with the mark scheme, specifically with mechanisms, if you're interested in organic chemistry, is to start annotating your mechanisms so that you're not just remembering them off by heart, but you're understanding the fundamentals of what's going on. Friedelcrafts acylation. Here I've kind of drawn what's going on in the middle, okay? So whether you're familiar with it or not, Friedelcrafts acylation is a way to add organic groups to benzene rings. So you will have either an acyl chloride or you have a haloalkane, and turn that into a very good electrophile, a very strong electrophile, and you will use the high electron density in the benzene rings to you know, attack the carbocation. When you do A-level chemistry, you know, you just remember where the arrows go without really thinking about what's going on, and annotating your mechanisms, although not required for the A-level exam at all, is a very good way to get an understanding of the movement of electrons, because this is something that you have to do when you get to university, and there's no harm in sort of teaching yourself how to do it from A-level. So here we have the haloalkane, which is going to react with AlCl3 to turn it into a carbocation. So I've drawn the carbocation already without drawing that step. You're very used to kind of drawing an arrow from the middle of a ring, or maybe even from a carbon to the carbocation. That doesn't really show what's happening with the electrons. So if you kind of want to practice the kind of chemistry you're going to do from uni, what you want to do is to take the arrow from the middle of the bond, which is where the electrons are, through the carbon that's attacking it and to the carbocation, because this shows you that the electrons aren't magically coming from a carbon. The carbon itself doesn't have a high density of electrons, the ring does. Then you have this hydrogen that you've explicitly drawn and the new R group that you've attached. But here the plus sign shows you exactly what carbon is electrodeficient. You know, if you just had sort of the six-membered ring, it's not very good, six-membered ring with a plus sign here, it doesn't really show you what carbon is now electron deficient or where the low density of electrons are. The low density of electrons are here because this carbon has now got still two shared pairs of electrons in a covalent bond, but this one now only has one hydrogen here and not any extra electrons. So drawing it through the carbon first of all shows you exactly what carbon is receiving the new R group, and then having the plus sign assigned to one carbon shows you exactly where the area of low electron density is. When it comes to annotating this diagram, then here you could write something like high electron density from the ring attacks the electrodeficient carbocation. So high electron density from the ring attacks the electron deficient carbocation. Okay, and that kind of reminds you of what is going on here. And then here you can write, this disrupts the stability of the ring. So this disrupts the stability of the ring, and then later on, you know, when we show the hydrogen losing its bond and giving its electrons to the benzene ring, we could say that the pair of electrons in the CH bond is donated back into the benzene ring to regain stability. Writing down annotations forces you to think about where the electrons are actually coming from and going to, and vice versa. Whereas just blindly drawing arrows doesn't really teach you anything about the movement of electrons, and it's the movement of electrons that is kind of significant in mechanisms. It also allows you to kind of spot patterns. I think sometimes it's easy to not think about really what's going on. And so, you know, every time you're confronted with a new problem, you have to think all over again. If we go back to the nucleophilic addition elimination reaction, when we have a nucleophile, it's because there is some kind of area of high electron density or a lone pair of electrons available. So here, the first attack, where we have either the oxygen attacking into the carbocation or the nitrogen attacking into the carbocation, when we write down our notes, our annotations, we specifically say the OH, or the oxygen lone pair, the N lone pair, or the N lone pair in this case, attacks into the CO double bond with partial charges. Or in this case, because there's a high area of electron density, or an area of high electron density in the benzene ring, it allows us to attack. And doing that means that when you're confronted with an unfamiliar mechanism, and you can see something, you know, you can see something that has the typical distribution of charge. So we have a delta positive and a delta negative here. And we can see something that we know has a lone pair, even though, you know, here you're familiar with water. Maybe now I give you an alcohol. You know that oxygen has a lone pair of electrons. You know that there's a distribution of charge here. So without maybe explicitly being taught the alcohol mechanism for this, you know that the first arrow is going to look something like this, because that's what always happens when you have oxygen lone pair, and that's what always happens when you have a distribution of charges resulting in partial charges on two atoms. Yeah, writing down the steps of the mechanism basically forces you to think about these things. Arrows, for example, always go from an area of high electron density to an area of low electron density. And so we would never see an arrow, even though that oxygen is attaching to this carbon-carbon, we would never see an arrow like this. And the reason for that is because the arrows are drawn from where the electrons are to where the electrons aren't, okay? Anyway, I've rambled on so much, and you know, I didn't actually know how useful this all has been. Hopefully, you know, you could take away one or two things. Maybe there's someone who's watching this who didn't know you could look at past paper questions. Maybe there's someone who didn't even realize that, you know, you draw your arrows from where there are electrons to where there aren't electrons. But hopefully there was some part of this video that you could resonate with. And yeah, other than that, I would just say, if you like this video, you like it, you know, if you have any questions about anything that I've said, you can comment below. And in this video in particular, I'm going to respond to the comments just because I have the opportunity to be helpful. If you're interested in attending an Oxford University, follow this page, because I'll definitely be making more videos on that. And apart from that, you know, follow me on Instagram so I can get more followers. Other than that, I don't really have much to say, but thank you very much for watching, and I will see you in another video. Goodbye.